I want to welcome Jakub. We
Hello.
debated his name already.
I'm just going to hold this. This is impossible to pin.
I think you can just...
Where?
easily.
By...
Yeah, that also works.
Okay. Hello?
Is it okay? Can you hear him well?
Yeah?
Good.
Is it okay? Okay.
Great. So welcome,
We're gonna
Jakub,
start, yeah?
and yeah, nice to see and learn more about WASI.
So, hey guys, I'm going to talk to you today briefly about WASI. But before we get on, let me, I guess, introduce myself. This is actually my first time at FOSDEM and first time presenting. So far it's great. So my name is Jacob Konka. I'm an R&D researcher at Golem Factory. For all the links and stuff, if you want to see more, you can find this on the FOSDEM events webpage for the talk. I tried to put everything there. If you have any more questions about stuff, just feel free to ask me, probably after, so that we can get through this. And then I want to show you some live coding as well. Hopefully we have time for that. So I'm a regular contributor to WASM Time and WASI, and one of the authors of WASI Common Library that's used in both WASM Time and Lucid WASI runtimes. And I'm going to get to that later on as well. I'm also a member of the WebAssembly community group. And you can actually, if you have any questions, just feel free to reach me on any of the handles. Private emails are fine as well. I don't mind. Right, so what is WASI? Very briefly, WASI stands for WebAssembly System Interface. It's a pretty new thing. I think it officially was announced last year around March, April time. Currently, it's being standardized by a community group called Bytecode Alliance. Now, Bytecode Alliance was formed in November 2019 by 4 founding members, that be Mozilla, Fastly, Red Hat, and Intel. All of those companies have actually something to do with WebAssembly and computation outside of the browser using WASM. So why WASI? Because we already have a scripting target. We have the unknown target for WASM. So WASI is trying to take WASM outside of the browser, unlike encrypting, and actually do it with security in mind first. So the security is based on capability-based security model, kind of like Cloud Abbey, Capsicum, or whatnot. So basically, it just will give you the safe and portable access to the host resources. If you want to learn more, have a look at the official website, which is wasi.dev. So how does it work? It's actually pretty simple. You take your C, C++, Rust binary library, mainly. You cross-compile that to WASM using to WASM 32 WASI target. You get your WASM module with some exports defined and imports that the embedder or the runtime should provide. You put that in the box, which is the sandbox. Could be WASM Time or Lucid. Now, the tricky bit here is that if you don't give it any capabilities, you can't really do anything except for example, read from student or write to studout or studer. If you want to do something fancy with your WASM app, you have to give it capabilities. So for instance, you could allow it access to the workspace there, / right? You could give it access to the host entropy, but all of this requires a capability, because by default, you don't get access to anything. So for instance, in this case, we're going to give it access to workspace and entropy, but we're not going to give it access to /def or clocks or in general time. This way, it's actually easier to give capabilities than take them away, because you can always forget about something and things just happen. So to put it into more context, for instance, oh, by the way, I'm using Rust. I hope, I'm not really a good C developer. I mainly use Rust, so sorry for this if you guys are not into Rust at all. So we can actually create a file in workspace directory. We can access the entropy with run thread RNG, but we cannot, for example, open devnull because we don't have access to that via the capability. So that's a no-go. And we also cannot call system time now because we're also lacking this. So this is cool. You can actually run apps that you don't really trust because you can enforce some degree of security using capabilities. Okay, so now what is the setting? The setting is fairly specific. So I work for Golem Factory. Golem Factory is trying to create it's a blockchain startup. It's trying to create like a decentralized market for computing where you can buy and actually sell computation power. You basically, if you have a problem, you call yourself a requester, you want to basically do like a map reduce kind of map. For the moment, you write your task, you then specify how it's meant to be divided into chunks, and then as a provider, so a person who's actually renting the computation power is going to compute that for you, each part of the SAP task. The trick here is that obviously it's untrusted. It's not like Amazon AWS or Google Cloud. You don't really trust the nodes because you have no idea who they are. So things can go wrong, right? They might have an incentive to lie to you or whatever. So that's why WASM and WASI come in handy, because they give us some degree of security in the sense that, even if you're a malicious requester and you're going to want to do something crazy, you can actually, with WASI, you can restrict what they're going to do. So in Golem, you can actually, one of the use cases, like you can write your own WAS maps and then send them to the Golem network. Now, how it works currently, we compile, you're allowed to compile your app to Emscripten, or you have to if you want to run it on Golem. That is because when we started looking into this, WASI wasn't even announced yet. That was end of 2018, I think. So I think Wasmer started doing some stuff in the sense that they were trying to take Emscripten and do something useful with it. And we basically, we were caught in this wee bubble. So we use Emscripten to do our bidding. Our sandbox is SpiderMonkey based, so we took SpiderMonkey JS engine and embedded that. And essentially speaking, you basically have to preload all the resources you want into memory, and everything is in the host memory. So that's also not ideal, plus you have to deal with JavaScript. So that's why when WASI was announced, it was perfect because you don't have to deal with JS, and you have a better way of tracking what capabilities you give. So the other thing that's actually quite tricky, and this is really tricky, is if you send it, if you as a requester want to get something computed, and the node is not trusted, how the heck do you tell whether what they returned is valid or not? Right? There is no trust, so to speak. So one of the ways of handling this automatically so that the user doesn't have to worry about this stuff is duplicating the work. So we call this verification by redundancy, and you can duplicate one task or a subtask into two, send it to two different nodes, and then compare the results. But in order to compare the results, you need determinism, because otherwise, if you want to do it by, which is the simplest way. If you don't have determinism, then good luck. It's actually, for every single use case or app, you would have to come up with your own way of verifying, which is just annoying. So this is where determinism requirement comes from. And I know it's also useful for blockchain guys who actually do the lower level stuff, like smart contracts. Obviously, there you need determinism on all levels. Right, so is WASI deterministic? Unfortunately, it's not. There is actually many avenues which give you non-determinism, and so WASM itself has certain things that might make it non-deterministic, and with WASI, we add even more things. So one of the obvious ones is obviously access to random device, and this is done with the syscall random get, which under the hood should call something like get random to actually access the host entropy. So the good news is that with the upcoming snapshot, which is in the works now in WASI, this will get its own module, like WASM module, and will require a capability to be enabled. So by default, it's going to be disabled. So this is good. So one less thing to worry about. The other one is system clocks. Same story as with random get. Currently, it's enabled by default, which is essentially a spec bug, but we were just speccing that out. But in the future, it's going to get its own module and will require capability, so that's another thing. Now, more subtle ones, and those are the interesting ones, are, for example, the contents of filestat. So this has almost direct mapping to what's happening on the host. And filestat returns things like the inode, the file type, and the worst thing is it's got access, modification, and control times. And this is tricky. It's not that easy. You wouldn't want, if you want to keep it in WASI so that you can use it in your deterministic program, you have to do some crazy stuff here, like, I don't know, filtering out parts of the struct. I don't think sticking anything emulated inside or like random numbers, like zeros or something is going to work. So this will require some more time The easiest thing would be to just disable it somehow, and we're going to get to that in a minute. This one is one of my favorites. So something as useful as listing contents of a directory can give you a notion of non-determinism, because guess what? Order of entries is dependent not only on the host, but also the file system used. So nobody makes any guarantees how you're going to get the results back. So this is also tricky, but it's also useful, right? Because it's better if I give you just, hey, this is the directory, just list the entries yourself, rather than me explicitly passing everything to you. That's not ideal. And actually, the list is quite long. I was surprised, because I started with a couple, and then people joined in, and it turns out that there is a lot of things that can go wrong. So, and I encourage and invite you to actually join the discussion, have a look. It's pretty good. So the link is there. It's under WebAssembly WASI issues 190. Right. So can we actually make WASI deterministic as it is now? So that was the question. The answer is pretty much. It's missing a couple of things, but we can still deal with that in a hacky way, but still. So the model that I want to present today is very straightforward. It's kind of like, you can think of it as delegated functions, I guess. It's basically, you export a function, let's call it compute, that takes in two WASI file descriptors. Now I'm going to get into what the file descriptors and writes are in a minute. And basically what we require here is that the input file descriptor only allows you to read from it. So you can only read bytes, and out, you can only write bytes to it. Okay, and that's it. And because of the capability-based model, we can actually enforce that with ease nowadays in WASI. Okay, so now what is the WASI file descriptor? It's an index into a table where we store capabilities, or actually entries, to the host resources. So the simplest one is 0, which doesn't have to, but normally points to standard input, 1 to standard output, 2 to standard error, and then the rest is actually what you pre-open. So in WASI, you call this pre-opening. So for instance, under WASI file descriptor 11, you're going to store an entry, which has quite a few fields, but the most important ones are the actual always handle, which is the host-specific handle to the resource. On Linux, that would be a file descriptor. On Windows, that would be a Windows file handle, for instance. So it can be anything. It can even be a socket and whatnot. And you also have base rights and inheriting rights. Now, base rights describe what you can actually do with the said file descriptor, whether you can read from it, you can write to it, if you can ask for the file stat, etc., etc. And inheriting rights are a bit more tricky. They are used, they will be the base rights of any file descriptor that's being derived from this one. So this is mainly useful in if you do things like path open. So if you, given a file descriptor to a directory, you want to open a file under that directory, right? So this is going to get the inheriting rights. So in our case, actually, it's not really important, but it's good to remember. Right, and then the WASI file descriptor rights. So as I said, and this is a powerful concept. So if the file descriptor has got fd read, you can only do 2 operations. I think actually 3. You can also set rights. But anyway, so you can do mainly fd read, right? But you cannot do, for example, fdp read, which is with the offset, because you don't have seek or tell, which is pretty useful. And you can do fd stat get, but this is harmless, because all it does, it returns the information about what rights it's got, what the file type is. So that's perfect, right? And you can actually do it nowadays. It's now no magic. You can actually enforce that. And the same with write. You can invoke fd write to write bytes to a file descriptor. And I want to emphasize the fact that file descriptor can be anything. It's an abstract concept, so you can point to any resource on the host. And again, fd stat get, right? But nothing else. And this is cool, because this already weeds out all of the syscalls that use file descriptors and paths. However, as I said, so have we just achieved determinism? Well, almost, because there's still this. And nowadays, unfortunately, this is implicit, so you get access to all of those. Call it ambient authority or whatever, right? So you can actually call that. And there's no way of, in a nice, elegant way of enforcing the at runtime not to do this. There are hacks to get around this, and I'm going to show it in a minute. But the good news is that this will get sorted with the upcoming snapshot when it stabilizes. So, do you guys have any questions until now? Yeah. Hi, Martin, by the way.
I was just curious why you didn't check the import in the binary.
Say again? If
Well, you just check in the binary, the header, the inputs, those things are not.
okay, I'm not sure. Yeah.
Say about checking those, if you are importing the symbols.
Sure, but there is no automatic mechanism of actually whitelisting. Oh, right. So I think what Martin is asking is why can we not just check when importing the module if it's if we're importing the function random get, right? Yeah, exactly. And this is my hack, but it's a hack, right? So no, that's a good question. But the nice way, an elegant way, is actually if you can do that, when you have the runtime spinning, you just say then you will say import this or include this module. But nowadays you can't do this, and that's the elegant way. But that's an excellent question. Yes. So any more questions on this, or can we move on to the examples? Are we good on time, by the way?
Yes, we're good.
Cool. So when I was trying to figure this out, I prepared a short set of examples, some of them very simple, one of them actually a bit more complicated to see, like a proof of concept to see whether this would actually work. And this is exactly what Martin was suggesting. I added that as well. So you can find them on my GitHub under kubecon WASI compute. And there is the description, how to compile it using Rust, current Rust, and et cetera, et cetera. There are 3 examples. The first one is hello compute. It's that easy. You read from input file descriptor, you uppercase, and then write out, just to test that it actually works. The second one is to verify that indeed the 2 FDs have the right rights. And the third one, a little bit more tricky, is actually taking some existing library, in this case, Flight text-to-speech library or engine. So what I did, I precompiled that from C to WASI object, and I included them for convenience in the repo, and then you can actually statically link that into this example, and it's going to create a compute function that does flight, not using a binary as such, but actually is going to create this deterministic function compute that allows you to read in the text input and then write it as a WAV file, and it works. I'm not sure maybe I'll be able to demonstrate this. But anyway, so feel free to have fun with this, break it, play with it, right? So since we've got some time, which is perfect, I can actually show you some of this stuff. Now I got rid of most of the things so that we can actually do it live here. Can you actually see this, or is it too small? Is it okay? Or should I make it bigger? Okay. Bigger? Is it better? Yeah, cool. Right, so yes, this is a bit tricky, and there was some discussion about this on the WASI Discord lately. WASI still implicitly assumes that you're going to define your main, so that the main entry point to WASI is _start. That is true, and because WASI is mainly based on the concept of lib pre-open and file system, and that you actually pre-open the directory and then you insert some stuff into it. If you do it my way, this stuff is not going to work, because essentially using libc here doesn't make any sense. You basically call the syscalls directly, so it's kind of like lower level. And all we do here, we actually export compute, and that's it. So that's why in Rust you need the no mangle, because we can't afford mangling, right? We actually need to be able to read it without mangling the name, pub extern C, and then we have in as the input WASI file descriptor and out as the output WASI file descriptor. And what Martin was saying, so I modified wasm time just a little bit so that I'm actually blacklisting random get and all the syscalls that can cause non-determinism. So they're not there. And if you do it at home or after this, and you want, just check it. try to invoke it, and it should panic. Basically, it should trap because the import is not there. And the next thing is, there's also a manual for this. You're going to see how we're going to run it. Basically, you added like 2 flags to WASM time that allow you to open, basically assign a resource to a descriptor directly. So you don't, because currently the way it works is that you can pre-open directories, but what I did, I tweaked it a little bit that you can pre-open files and actually reduce the writes to either read or write, and that's it. Okay, so that this actually works. Right. So as I said, the hello was meant to basically open in, read from it, uppercase, and then write to out. So very quickly, we're going to create some temporary buffer here. Let's say 1,000. Obviously, you would do it in a different, more like safer way, but we don't care about this here. Now, the thing you need to actually read from FD read is an array of IOV extracts in WASI. So this is IOVEC, and then it requires a pointer to the buffer, in which case, that's going to be buff, and then we're going to take pointer out of this, and then also the length. Okay, so now basically, we basically pack the buffer into a WASI struct that we can then pass into FD-read and read in the contents into it. So then what we do, we call, and this is unsafe for obvious reasons, we call the FD-read syscall, which basically takes the input file descriptor, in this case, rn. Actually, if you call it without, it's going to trip immediately because we don't have the FD write on the input file descriptor, which is exactly what we want. We just want like a one-way stream, right? And there we create the array of IOVEX. In this case, it's only 1. And that's it. So this is going to read the contents of whatever we point at with input WASI file descriptor into the buffer. Then what we do, let us actually do the uppercase. So this is from UTF-8. Oh, and I should probably have that. Yeah, you should probably do like the proper error handling here, but I'm not going to even bother with this. So from UTF-8, and that is going to be the slice we just read into. The buff, and then however much we read, and then unwrap, and then we can do to uppercase. Okay, so that should be to uppercase. Then unfortunately we need to create a CIOV extract, which is used for actually writing out in WASI. It's pretty much exactly the same as the IOVEC in the except for the fact that the pointer is const, it's not mutable. And it's not, this is actually to string. Then. And we just call the syscall, which is CIOVEC. And that's it. So that's the first example, which basically reads in, uppercases it, and writes out. Any questions on this? Yeah?
Is there any from trace implementation to convert from a string to a IOVEC?
No, but again, if we were doing like a library out of this, then yeah, that actually would even make sense to create something like libc. That would be above the raw syscalls. Like, I don't know, stream in, stream out thing, but I didn't have time to actually do this, so yeah, that would be a great idea to actually have a from or try from or whatever, right? So having this, let's try and compile this. I highly recommend Cargo WASI tool that was written by Alex Triton. It's great. It actually saves you a lot of hassle with passing in targets and stuff. You can even do testing. So I'm going to actually use Nightly because I know that Nightly is up to date with the current snapshot for WASI in Rust. I'm not sure whether it's stable caught up yet or not, but you can have a look. So this is going to build it. It's going to be all, yeah, okay. Actually, let's go into Hello Compute. Right. So it built it in Target. we have the hello compute WASM, right? So now about the invocation. So I'm going to do this with tracing on, so I can actually have a look what what the call sequence is for the syscalls as well. So this is useful for tracking what's going on. Sometimes it's not enough. Sometimes you have to add some debugging because there's too much stuff going on. But for starters, this is pretty good. So the flags I added are pre-open read, which is going to take some input file in, which I haven't created yet, so this should actually shout at me. And this is going to use that as the stream in, and then pre-open write, which is basically going to save it to a file out. And that's it. And I'm going to use the experimental argument invoke for WASM time, which basically allows you to, instead of running start of the WASI module, it allows you to basically run any export. Okay, and that's it. There's absolutely nothing there. Oh, and because our function requires input file descriptors, we're going to pass them as the last arguments. So, okay, that's pretty good. So we indeed haven't passed in the anything. Okay, so we have this, and when we run it, there is a lot of stuff happening here. The first bits are not really that important for us now. It's basically telling you that it's inserting certain pre-opens into the WASI context, which is basically this table that we're talking about. One of them is FD11, and FD12 should be somewhere here, but I can't see it. Maybe it's FD10. Anyway, so there we have FD read, and it read 20 bytes. Should be about right. And then it should write out the same amount, okay? Even though the buffer was 1,000. So we can test that, and yeah, there you go. So this works. If we tried, so we can, this is kind of cool because you can play with it now. And if you tried to call something crazy, right, like actually random get, it's mutable, right? Yeah. And yep, wrap. Okay, cool. So this should not work. And let's have a look. Right. Yeah. So I guess this is what Martin was suggesting here. Basically, the import random get is not found in the module. So you can actually do that now, but it's not clean, right? You'd have to maintain your own runtime, and I'd like to avoid this. I'd like everything to be like according to the spec. That'd be amazing, right? So the next thing I wanted to show very briefly is actually, I'm not going to write that out myself. So that's the test that you can find, the test example that you can find actually in the repo. Essentially, it doesn't do anything complicated. It basically calls fd_get on the file descriptor, and then we can actually compare the write space. So we're expecting inheriting to be 0. For the input file descriptor, we want the WASI writes to be read-only. So this is WASI writes fd read, and for out to be writes fd write. So if we run this, yeah, it's fine, right? Everything was success. You can see it here, and then the output is 0. So that means no errors. So the writes are there, and they're properly constrained. So for the most complicated example, there is a slightly bit more code here. So this is actually taking the C library and adds Rust wrappers on top of it, and actually you can do the flight. I wonder if I can show you that actually works. So I'm not going to bother actually going through this code because there is quite a lot of, it's very, very flight specific. Just trying to, hook in the C library in Rust and basically just invoke it. That's it. There's absolutely no magic there. It still follows the same architecture that you read in, you do some processing, and then you write out. So I wonder if I can show you guys. Right, so now out should be a WAV file, and it is. Right, I'm actually going to move that to Should be easier. Right, do I have? Right, forgive me for this, and we'll see if it works. Right, let's open up.
Hello, how are you?
Right, so it actually works, right? So you can actually do, oops, sorry, you can actually do some more complicated stuff with this as well. Obviously, this is just an experimental thing, so it's meant to break. But I guess it's a good start, and we can build from there. So going back to this. Right, so any questions? Because I think we've got like 5 minutes left or something.
Yeah, 5 minutes for questions, yes. Questions, so thank you very much.
Thank you.